Right. Right. Let's start with questions. Maybe I might repeat some of the questions here, but it's fine. It's for understanding. Okay. Here we are given letters to from A to E. Okay. For six compound. Okay, we have this compound, this one, this one, this one, this one. Okay, what are the questions? Okay, can just simply interpret those. This one could be which compound. This is supposed to be an alcohol because of the special thinking here. Okay, this is an alcohol. This is an aldehyde. Why? Because the double bond is always at the end. Okay. We are told here if what this is. Okay. Maybe they can say we must draw this one. Okay. But your alcohol should be at the end. Okay. Here they are saying it butyl-1. Okay. Meaning your double bond should be on the second. That double bond should be here. Okay. Because it's butanol. Okay. These things are much simpler, guys. Right? Maybe they can ask us to name the structure. Okay, we need to be careful of the longest chain here. I think the longest chain would be from here all the way there. Then the first branch would be this one, the second this one. Okay, let's see what they're asking. Okay, let's not be too ahead of us. Okay, write the letters that represent each of the following: alcohol. But it's not just an alcohol, guys. It's a tertiary alcohol. Let's go and see. Okay, it's this one. Why is it a tertiary alcohol? It's because the C, the carbon that is bonded with that alcohol, is also bonded with three carbons, being this one, and that one. For classifying an alcohol as tertiary, primary, secondary, we consider the carbons, okay, together with the alcohol groups. In this case, there are three carbons that are bonded with the one that is bonded with alcohol. Hence, we are saying it's tertiary. Okay. So the first answer is A. The first answer is A here. Okay. Aldehyde, we said it's B. Okay, so it's B here on the aldehyde. A ketone. Do we have ketone here, guys? Okay, we have this one. It's because of this one. Hence, we are saying it's ketone. Look at the ketone. They have on the end one here. Okay, their suffix is one, and here it's one. That's the only difference. That's the only way we are able to say D is in ketone. Okay. A functional isomer of compound B. A functional. Okay. Now, guys, it's not a structural. It's a functional. Okay. Meaning you need to change a position of the functional group. Okay. Let's go to B and see how can we change. It's butane. All right. And you can, it's this one. It should be this one, because this is also a butane and this is butane. What do I have changed here? It's just a double bond, and the double bond now is at the beginning. You see, here is on the second carbon, here is at the beginning. Therefore, this is just a structural isomer, because this and this are exactly the same. The only difference is where the functional group is. Okay, so the answer is B. Answer is B then. It's B. Okay. Write down the IUPAC name of the following. Okay, as I said, compound B. Where is B? Okay. I forgot what to name this one. Let me think about it. But it should be I don't know whether we included the last name. We'll see on the solution. I don't remember if how do we name a compound with an aldehyde compound. Okay, we'll see on the solution. That's fine. Compound E. Okay, let's go to E. As I said here, we need to count the number of the C. The longest chain would be a parent name. Okay, I'm thinking it will be this one. 1, 2, 3, 4, 5, 6, 7, 8. Okay, we have 8 here. We have obtained already. Okay, 1, 2, 3, 4, 5, 6, 7. This is not a longest chain. Even this one would be not. Okay, 1, 2, 3, 4, 5, 6, 7. This is not a longest chain. Also, the longest chain is this one. It starts here from there, or it could be start here. Okay, how do we name? Where do we start? Do we start here or here? It depends on the closest chain. Okay, it depends on the closest is it still continue? Okay, it depends on the closest chain, okay, or substituent. 1, 2, 3, 4, 5. We only get to a chain on the 5th carbon. From this side, 1, 2, 3. This is already on the 3rd one already reached a chain, so we start from this side. Okay, what is this and what is this? Okay, so we have branches on the 3rd, 2 branches on the 3rd carbon. What are those branches? They are methyl. Okay, so we can say we have 3 hyphen dimethyl. Okay, and you also on the 4th one have a branch. What is ethyl, because it has 2 carbons. So which one start? Is it methyl or ethyl? It has to be alphabetical. Ethyl. E comes first before M. Okay, so it is 4 hyphen ethyl hyphen 3 dimethyl. Then the compound name, which is 8 carbon octane. I think it's octane. Okay, let's go and see on the memo what they're saying there. Okay, as we said here, those are the answers we have. Okay. It's butanol. That's what I said. I don't remember what to call that. So it's butanol. The N name of an iodine and with NAL. Okay, it's butanol. What about this one? What's going on here? It's 5 ethyl 6 diol. Alright, there was, let's quickly go back. We made a mistake here. Let's quickly go back. We haven't seen this one. You haven't seen, that was our mistake. Remember in the previous video, we take preference of what? We take preference of the functional group. If we have a functional group within the compound, because this is the alcohol, if we have a functional group, therefore we start from the side that is close to the functional group. Okay, let's count. 1, 2, 3. We reach a functional group. Let's count. 1, 2, 3, 4, 5, 6. So this is not an option because it's too far from the functional group. Okay, hence we will start from this side. Okay, so the functional group is on the 3rd one. Okay, let's count then. 1, 2, 3, 4, 5. Okay, on the 5th one we have ethyl. So 5 hyphen ethyl. On the 6th one we have this one and this one, which is 6,6 dimethyl. That's what they said there. Our program was not able to identify that we have this one. Okay, we need to be careful of that. Okay, it's 5 ethyl hyphen, comma, because you're separating a number from a number, so it must be a comma. A word from a number is in hyphen, dimethyl, octa, octanol. But you are saying where this functional group is on the third one. Okay, that's what it is, guys. Okay, let's quickly go back to the question and see, do we still have other questions here? Define a positional isomers. As I said, it's a compound with the same molecular mass or same molecular formula but different structures. Okay, let's go and see what the memo is saying. Let's go and see what the memo is saying. Compound with the same molecular formula but different position of chain, substituent, functional group, parent. Okay, that's what I just said. Write down the structural formula of compound of a positional isomers of compound C. Let's see compound C. Positional. Okay. Let's see. Here we'll simply change. We'll draw this compound, but we'll simply change the position of an alcohol to not be on the first carbon, but to be on the second or on the third. Okay, so that's the only thing we'll do. It's the same thing as this one, but here it's gonna be oxygen, hydrogen, even here. Then we can place, instead of this hydrogen, alright, since it's butane and this is butane, so instead we will have to substitute this and have alcohol group or functional group, meaning we'll have oxygen here and hydrogen here. Alright, that is a positional because we're changing a position. Positional isomers of this one. Okay. Where are we? Okay. I read the structure formula of this one. Okay, let's go and see. D is easy to write a structural formula because it's simply this thing. You simply draw a structure of this thing. You simply change this position. You bring back this oxygen here and this one here and bring a double bond here with high oxygen. Oxygen. Okay, you simply change this position to here. That's all for this one. Okay, those were just easy marks, I think. Okay, the organic acid that will react with compound C to form a butyl propionate. Remember, they are saying this is butyl, meaning compound C is it's supposed to be alcohol, okay? But they are saying here is propionate. That's the key word, propionate. For us to have an ester, it means that we need an alcohol and acid. What is that acid? Carboxylic acid. But what is it now? It's supposed to be propanoic acid. Propanoic acid. We're taking it from here. Okay, let's go and see from the number. Alright, guys, we are also at home here. We might be having some disturbance. Alright, just bear with us. Okay, that was functional isomers because it was at the beginning first, then we just had to change the position. You get your 2 marks, and even here get your 2 marks. Okay, because this is a positional isomers of compound. Okay, so that was a structure which is propionate. If this is an axis that you were drawing here, okay, this is proper now. Okay, I think we end here. Okay. Let's see what else do we have. Okay. I don't know how to get years yet. I don't know how to get years yet. I don't know how to get years yet. But it's fine. Let's try and see how far can we go. Start with the vapor pressure versus temperature. Remember, vapor pressure decreases when the intermolecular forces increases, as we said previously. Okay, increases if intermolecular forces increases. Okay, versus temperature graphs for 3 organic compounds. Okay, maybe they will say we must identify what are those compounds. Okay, let's see. I like to interpret graphs because they are much interesting. Okay, belong to different homologous series, meaning they have special qualities, of course. Okay, it's a vapor pressure on this side, and it's a temperature this side. Okay. As you can see, compound X appear to have a highest vapor pressure because it needs less energy. It must be a weak compound like alcohol. This one. Okay, let's see.